everyone, and welcome back to our course. In this lecture, we are talking about three normal forms. These are standard rules for designing an organized database. So let's get started. Normal forms are standard rules to test if a table in a database is well designed. The first normal form goes, a table should not have any column with concatenated or compound values. Let's look at an example. Do you see something that is wrong with this table? Here we can see we have a column that is actually containing concatenated values, and that is the column first name, last name. Instead of having a column with concatenated values, although you might intuitively think that a name is one column, you have to be careful. It's best practice to instead split a name into first name and last name. So here, this table does follow the first normal form, whereas our previous table did not. Let's take a look at the second normal form, which goes, a table should have every non-key column fully defined by or dependent on a primary key. This one is a little more complex, so pay attention. Take a look at this table. Do you see any potential problems with this table? We have properties affiliate ID, course ID, revenue, and course instructor. Being able to understand a table and what it's trying to describe is a valuable skill and important, especially when you're applying for a company. In this case, we have a table that's describing the sales of a course across different affiliates. So for the affiliate Mammoth, the Hello Coding course generated $1,000 in revenue, and the course instructor was Mammoth Interactive. For the affiliate Sabre, the course Hello Coding generated $2,000 in revenue, and the course instructor was Mammoth Interactive. Then for the affiliate Rhino, the course ID Excel Masterclass generated $3,000 in revenue, and the course instructor was Mammoth Interactive. Here, the primary keys are the affiliate ID and the course ID. Then we have the revenue column, and this is clearly identified by the key because a revenue here is just a value. However, the course instructor is not clearly identified by a primary key because the course instructor is better organized in a separate table. So instead, we would put the course instructor or author into a different table that was matched to a course ID. That way, if you wanted to find the course instructor, you would just go into the courses table. So you would cross-reference a table. You have your affiliates table, but if you wanted to find the course instructor, you would just cross-reference the courses table, and you'd be able to find the author based on the course ID. So that is an example of a relational database where you can cross-reference a table. Let's take a look at the third normal form. All non-key columns should be independent of each other. So take a look here. We have another table. This has attributes product, food, category, and section. We have entries Granny Smith, which is an apple, which is a fruit, which is in produce. We have barbecue chicken leg, which is a chicken leg, which is part of chicken, which is in the meat section. We have whole wheat bread, which is a type of sandwich bread, which is in the bread category, which is in the bakery section. So here we have a table that's describing products in a grocery store. Now you can see here the two columns, category and section, they actually follow from the food column, and you could even say that they're derived from the food column, potentially. So here they follow from food because the food apple will always be in the category fruit, which will always be in the section produce. So they're linked in a way. So instead of having to put category and section into this table of produce, it's best practice to actually put that data into a separate table. So here, instead of using one table, it's best to use two, where the products are just kept as the product and the food that they're in. But then the food contains the category and the section at the grocery store. This way, you will have two different tables that will be smaller instead of having one huge table with a bunch of data in it. So it's best practice to split your tables where possible, such as here, where the food item, it can be mapped to the category and the section. That way, if you wanted to reference where is the Granny Smith product in my grocery store, well, you could go to the table of products and find Granny Smith. Then that table has one more column, food, and you could find that Granny Smith is an apple. Then you could go to your food or grocery store table, in this case the food table, and you could find apple. And you're cross-referencing because you know Granny Smith is an apple, so you go to the food table and you cross-reference the apple, and you can find that the apple is in the fruit, which is in the produce. So you know that Granny Smith is in the produce. And this is done very, very commonly cross-referencing because it allows you to modularize your data. Instead of having all of your data about the product inside of one huge table, you split that data into different tables, and that makes it a lot easier to work with. So that is how to follow the 3 normal forms to check that your database is clean and organized. There are many other practices for building an organized and ordered data set and database, but these were the most common and fundamental steps to building an organized database. That does it for this lecture. I'll see you next time.